Hi guys, myself Viha Suhasbhat from Sri Venkateshwara College of Engineering. My USN is 1VE22IS059. And today we're going to talk about the difference between one-way and two-way ANOVA. So what is ANOVA? Analysis of variance or ANOVA is a statistical method that stands at the heart of comparing means across different groups. Its essence lies in partitioning data variability into components attributable to various sources of variation. ANOVA serves as a fundamental tool for researchers in various fields such as psychology, biology, education, and economics. By enabling the comparison of multiple population means simultaneously, ANOVA assists in determining whether at least one group stands out in contrast to others statistically. Utilized widely in experimentation where multiple factors are at play, ANOVA guides practitioners in concerning the influence of factors on a dependent variable. This introduction will basically pave way to understanding the the subtleties and applications of one-way and two-way ANOVA, aiding to selection of the appropriate statistical test for complex data analysis. So one-way ANOVA, definition and purpose of it. First is unidirectional analysis. One-way ANOVA scrutinizes the effect of single independent variable or factor across two or more groups. Each group represents a level of that factor, enabling the analysis of differing impacts on the dependent variable. The second is internal comparison. This analysis quantifies variance within group datasets against the variance between different groups in the quest to gauge significance difference between means. Next is real-world applications. One-way ANOVA is frequently applied in scenarios where multiple treatments or conditions need evaluation, such as testing the effectiveness of different dose levels of a drug on patient recovery rates. Now, two-way ANOVA. First is factorial design. Two-way ANOVA extends the analysis to two independent variables, thereby assessing their individual effects and interaction effect on the dependent variable. Interaction insights. The method determines whether there's an interplay between factors, an insight pivotal in experiments where variables are suspected to influence each other. Broader applicability. Its application spans complex experimental designs such as understanding if patients' response to treatment vary by sex or age group, tapping into multi-phased variables. Key difference between one-way and two-way ANOVA. So the first are factors involved. One-way ANOVA deals with single dependent factor, while two-way ANOVA considers two factors, enabling a more in-depth analysis of data. Interaction effects. So two-way ANOVA can investigate the presence of interaction effects between factors, which is a feature that is not available in one-way ANOVA. Next is complexity and use case. The complexity of two-way ANOVA caters to broader applications where the multiple variables may affect the outcome, unlike the simpler single variable focus of one-way ANOVA. Factors in level in one-way ANOVA. So the factors can be medication types, diet, exercise regime, etc., where levels are ABC, low carb, high protein, vegan, cardio strength, flexibility, weight training, etc. And the description of these follows. Factors and levels in two-way ANOVA are first examples that include temperature levels like low, high, medium, etc. Second is simultaneously the product types like plastic, metal, wood, etc., which is trusted to study material impacts. Next is interaction, the interaction effect that could reveal whether certain materials are more sensitive or not. Assumptions and conditions for one-way ANOVA include independence, normality, and homogeneity of variances. In independence, we see where each sample drawn must be from populations that are independent of each other to avoid biased results. Normality shows the data in each group should approximate a normal distribution to validly compare means across groups. Homogeneity of variances. ANOVA assumes that all groups have the same variance, which is crucial for the test's accuracy. Next is assumptions and conditions for two-way ANOVA. The factors first includes the test that involves two independent variables that could potentially affect the dependent variable. Then assumptions like independence, normality, and homogeneity of variance are key assumptions similar to one-way ANOVA. And then an additional assumption in the absence of significant interaction affects unless the interaction itself is being tested. So here is a solved example of a one-way ANOVA for the given data in the table consisting of three variants A, B, C. So we first found the sum and square and then found the controlling factor and the TSS, SST, and SSE, and then formulated it into the table and then found out the 5% level of significance for the same to decide whether the null hypothesis is accepted or rejected. This is an example for a two-way ANOVA. Again, we are finding out the table for the given data, which includes 4 plot lines with varieties of weight. Here again, we're finding sum and square for both rows and columns, finding CF, SSS, TSS, SSR, SSC, and SSE, and then formulating a table and then finding out FR and FC, and figuring out if the null hypothesis in each case is accepted or not. Thank you so much. Have a great day ahead.